Alright, it is time for day number 2 on permutations and combinations. Yesterday I blew your mind with the idea that we've been mispronouncing lock combinations. It should be lock permutations. Today, I'm going to let you do something that's never, ever done before. If you want to feel awesome today, pay attention here. Like and subscribe. Let's go. Alright, so... Okay, counting rule refresher. I'm going to skip over this because our time is it's kind of wasting. Alright, okay, permutations. Alright, now we talked about this yesterday. Remember, permutations, there's order. Okay, there's a ranking, I like to call, in it. Alright, combinations, there is no rank. Alright, so I want you to think through this, this thing called a factorial. Alright, and sometimes you might see this. It's an exclamation point. It's called a factorial. And take out your calculators. If you don't have a calculator, you're going to need one today. So pause it. Go grab a calculator. Make sure you return it. It's an exclamation point. Alright, what does a factorial actually mean? Alright, now remember that counting principle? How if we have 5 shirts, 7 pairs of pants, we just multiply them together and it tells us how many different options there are. Well, this is kind of what this does, is factorial. It's kind of a cool little thing. Basically what factorial means is it means I'm going to start with 3 here. Doesn't mean it's an excited 3. That was, I don't know, that was stupid. That was a really bad joke. You're going to start with 3, and then you multiply down until you get to 1. Now, technically, you don't even need to put 1, because multiplying by 1 is itself. And so what is 3 factorial? Well, 3 factorial is going to be 6, because 3 times 2 times 1 is 6. Now, like I said, you don't technically need to put 1 there, but yes, you go down to 1, whatever, okay. So what's 5 factorial? Well, honestly, guys, 5 factorial is 5, 4, 3, 2, 1. Alright, it's that easy. What is 5 factorial? Well, that's going to be 20, times 3 is 60, times 2 is 120, times 1 is 120. Find that exclamation point on your calculator. See if it even exists on your calculator. It's got to be in there somewhere. Maybe it's on a stat button or a math probability, but there's an exclamation point. See if you can find it. Or otherwise, Google it. Okay, you're on a computer right now. Google your calculator. Figure out how do you do factorial on your calculator. If you got a Mickey Mouse calculator, probably not going to do work. Probably is not going to be there. All right. So here's the really cool part. This used to be like my least favorite topic until like 2 years ago, and now this is like my favorite thing to ever talk about. How many ways can this class line up? All right, so I think you would all agree that this is going to be a permutation because this has a rank. Because about 3 minutes before the bell rings, this miraculous thing happens in class. Everybody starts putting their backpacks on and starts wandering over to the door to stand and just wait and go, man, that clock's taking a really long time. Okay? So we all line up, and obviously you want to be first so you can get out. And some people in our class actually try to leave other classes early so they can get out to lunch. You know who you are. I saw you. Anyways, so how many different ways can our class of 31 students line up? So we have 31 students. Okay, well, what if, what if we had, Rashawn line up? He could be first place, right? Okay, so what if Rashawn didn't line up first place? What if it was Carly? Maybe Carly did it first, right? Or, anyways, you get the hint. This could be any of the 31. So how many possibilities is there for first place? There is 31 different possibilities for somebody who could be number 1. Once you have first place assigned, now who can be second? And I think hopefully you'll understand there's no longer 31 people. There's 31 for first place. Now that first place has been assigned, now there's only 30. I might have to do this lesson in 2 increments, because I don't know if I'm getting through in 15 minutes. Does this kind of make sense? Third place, how many different ways can we line up for third place? Well, once first and second's been picked, there's only 29 people left, right? So do you kind of understand what's going on here? What's going on is that this is going to work all the way down until 31st place, and there's only going to be one person left that could be in 31st place. So what do we do here is we just multiply all the way down, okay? Now somebody said, man, I don't like doing this. This takes forever, multiplying all the way down, and we're going to have to go dot, 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 and then all the way down to that last place, which will be, there's only one person. So this is factorial. So how many ways can this class line up? It's really 31 factorial. That's how many ways. So I'm going to take out my nifty calculator. I'm going to go 31 and factorial. All right, I get this amazing answer. How many ways can our class line up? 8.22, and then it says that e to the 33rd. Now, do you guys remember? I told you this last week. What does that mean, that e to the 33rd? That means that this is going to be a very large number. It means I'm going to move this over 33 times. Now, I'm not going to do that. Can you imagine how many ways we can line up at the door? There is so many. We could line up at the door different way for the rest of eternity. I mean, there is so many ways to line up the door. It's unreal. Okay? Here's a really cool thing. Now, this is not part of slides. This is not part of slides, but I saw this on Vsauce. If you guys don't know who Vsauce is, you better look him up, because he's pretty good stuff. He's what we call hot spit. Okay, he said, grab a pack of cards. And if you want to do something cool today, do something that's never been done before. He said, take a pack of cards, brand new pack of cards, mix them up a couple times. He says, like, mix them up 3 or 4, maybe 5 times. Give them little shuffles, little ruffles, whatever you need. Okay? You know, give it a couple more shuffles. And then take a look at the beauty of this deck. Because it is said that probably these cards have never been aligned in the same way ever in history. Ever. With a 7 of hearts in the front and a 6 of hearts next. And I know you're like, that's ridiculous, Mr. Sheevy. You know how many card games people have played? Alright, I want you to do this. How many ways can a pack of 52 cards be arranged? Okay? You're going to go 52 factorial. Alright? When you type in 52 factorial, that's right, I do my own sound effects to math. I get 8.06, and then I get that e to the 67th power. That means I have 8.06, but I have to move that decimal over 67 times. That means, you know how many ways that there is to rearrange a deck of cards? There is an awful lot. And we can pretty much be sure that that way has never been arranged like that before. There you go. Amazing moment. Okay, now let's get talking about what we're doing here today. All right, how many words can you make using letters A, B, C, D, E, and F? All right. Okay, so first of all, I could write A, B, C, D, E, F. I could maybe go backwards. Right? Or maybe I want to go Edis a big F. Or maybe big Dave. Okay, there's tons of words I could write, right? How many ways can I write them? Well, there are 6 different words. So how many ways can I have a first digit in this? There's 6 ways. What about the second digit in the word? There's 5 ways, right? Okay, because we've used a first digit up already, right? So now there's only 5 digits left for the second place. How many ways can I arrange the third place? Well, you got it. There's 4 ways, right? So we're going to keep counting down. This is basically, how many different ways? 6 factorial. Okay, now my mouse is pretty much dead. So I'm going to replace the batteries, and I'll be right back. Alright, okay, so 6 factorial. And if you go 6 factorial, I'm going to put it in here, 6 factorial. I get an answer of 720 words. Now, they're not going to make any sense, these 720 words. But there's 720 ways I can rearrange A, B, C, D, E, and F. Pretty sweet, huh? Alright. Cool, cool, cool. Alright, now, 8 runners are running in a race. Boom! And how many different ways can these runners come in first, second, and third? This is permutation because order does matter. Okay, so here's the beauty about permutation. Okay, how many ways can 8 runners come in first? Well, how many different people could we have come in first? 8, right? How many different ways, how many different people can come in second then? Once we find our first place, there's only 7 people left. And third place, there's only 6 people left. Okay, now here's the cool part. With this, not just saying how many different ways can they be rearranged, all 8 runners. I want to know just first, second, third. So I don't care about all the other ones behind. This stuff doesn't matter to me. I only care about the first 3. And there's 8 ways for people to come in first, 7 ways for them to come in second because the first place has been taken, and then there's 6 people who could fill in that third place. So this is kind of another way. Permutations, basically, if you think about it, I just have to multiply those 3 together, and I go 8 times 7 times 6. 8 times 7 times 6. And I get 336. So there's 336 ways for this to happen. Okay, I'm going to teach you a cool button on the calculator. To me, I don't use the button on the calculator because I think it's pretty easy to do this. But there's a permutation button on your calculator, and it's called. You look for it. It's a big P. All right. Usually has like NPR or something like that, like public radio or something like that. It looks like this. NPR. The formula is all like this. If you actually want to figure it all out, it's don't waste your time looking at the formula. But you'll find a button on your calculator that looks like this. All right. Okay. Once you find that button on your calculator, here's what you'll just type in. Okay. Oh, my bad. No. All right, here we go. Here's what you'll type in. You will type in, there's 8 total people. Okay, and I want to know the permutation of rearranging 3 of them. And you go do that in your calculator. You're going to go 8. Then you're going to press that P button. Okay. Everybody practice. And then you press the 3. And you press equals, and you're going to get that same value, 336. Same thing. So there's 2 ways to skin this cat. Okay, 2 ways. You can do the P button, or you can think logically, which I like thinking logically myself. Or not. Maybe you don't. All right. Sorry, I'm starting to slow down. It's getting late. All right. Let's do one more example, and then we're done with this episode. You'll have to watch one more episode to finish off this lesson. We start a math club using just the people in this class. And how many ways could we select a president, vice president, secretary, and treasurer? Okay, I'm going to set this up, and then you guys can see. All right, I'll be right back. Okay, so how many ways can we select a president? That's the highest position. There's 31 people in our class, so we could have 31 different people be president, possibly. Once we've selected our president, then we only have 30 people to select our vice president. Once he's been selected, we only have 29 people to be secretary, and then 28 to be treasurer. The final answer is just multiply those together. I'll be right back. Final answer is this. Okay, you could also use your P function in your calculator. It would be 31P4. All right, I'll be right back.